Thank you so much for having me. My name is Amy Manefield, and as introduced, I am the Head of Data Operations for the NUA project, which is sponsored by the Geospatial Commission. Today I'll be talking about applying real data to the data model. So we're a little bit further in our journey than what Victor was outlining in terms of where he is in his journey with that project. So I just want to talk today a little bit about some of the challenges that we've faced in that sort of the build phase of the project and how we've been able to deal with those. So the Geospatial Commission, it's an expert committee within the Cabinet Office of the United Kingdom Government, and it was set up with 4 key missions: promoting and safeguarding the use of location data, improving access to better location data, enhancing skills, capability and awareness, and enabling innovation. All of this with the goal to unlock the power and value of location data within the United Kingdom. So NUA has become a key part of that goal, as also stands for obviously the National Underground Asset Register for the United Kingdom. It's an interactive, secure and fully comprehensive digital map of underground pipes and cables. It will streamline the way data is shared between asset owners, allowing data to be made available to those excavating immediately, and also enabling missing or erroneous data to be fed back to the asset owner. This is bringing together underground data sets from more than 650 separate asset owners. This means 650 different schemas and 650 different sources continually updating their data to a centralized platform in one single harmonized data model. Getting this to work once will be very hard work, but getting it to work sustainably into the future, when there are so many individual organizations contributing, will be quite the feat. Just a bit of background information to contextualize the scale of the problem we have in the United Kingdom. There are a few stats. We have 4 million kilometers of underground services, which is enough to go around the entire world more than 35 times. And all of this information about these assets are held by over 650 separate organizations. This is in varying formats, scales, and degrees of quality. This makes it incredibly difficult for the asset owners who are required to share their data, but also the planners and excavators who need it to carry out their jobs safely and effectively. As a result of the lack of interoperability of the data and the varying scales and formats the data is currently held in, this contributes to roughly 60,000 accidental strikes every year and puts lives at risk. Therefore, the GC started the pilot for the NUA project in 2019 with the purpose of understanding whether pulling together all this information could be done and to explore the benefits of what it would mean. Working in 2 discrete areas, London and the northeast of England, the pilot collected vast amounts of data to better understand the breadth of information we would be hoping to capture within the single harmonized data model. We learned a great deal about how this could be implemented on a larger scale and on a more permanent basis. Understanding the feasibility of the data transformation on such a scale was key to deciding whether the project would be able to continue into the later stages that are outlined on this roadmap. I'm happy to say that in September 2021, we entered the build phase of the project, and we are currently working towards rolling out a permanent platform to 3 areas: Wales, the northeast of England and London for March 2023. With the rest of England and Northern Ireland to follow, Scotland already has a similar platform in place, which we're not looking to replicate or replace. For the pilot, it was clear that all the data from each source would need to be transformed into a single harmonized model so the information could be easily understood by whoever was looking at it. This would allow clear information of the assets within an area to help inform the men and women digging those holes on site to help lead to less utility strikes. At the beginning of the pilot, the OGC MUDDI model, or the Open Geospatial Consortium model for underground data definition and integration, was in its infancy, with the NUA project being the first project to employ the standard and feed back into the OGC with learnings. The model structure builds hierarchical to allow for flexibility and specialization. We employ the UK excavation profile, which fits the use case of our project. We then build a further layer of the hierarchy to incorporate our specific NUA platform model, being able to tailor the schema to our specific data and use cases. The model is flexible enough that if the use cases were to be expanded, so could the data model be expanded to allow for the additional data required for the use case. Within the pilot phase of the project, we learned a lot about the sorts of challenges we were going to encounter when building the platform as a permanent solution. The model needed to be flexible in order to sustain change without having the entire database needing to be retrofitted. On this slide, I've outlined some of the key learnings we have subsequently incorporated into the data model for the build phase and beyond. One of the biggest themes in terms of learnings was around the minimizing of hard or structural constraints. This was a very important feature that was learnt from the pilot to minimise the need to republish the data model for what could be seen as minor changes. As opposed to hard constraints enforced through the structure of the data model, instead conventions were discovered to be a better way of imposing rules on the data transformation to the data model, as opposed to restricting the values available by the structure of the model itself. These conventions were documented and used within the implementation. Subnetworks were also developed within the hierarchy of the data model to represent data which were spatially associated to one another within a certain network or domain. Alongside this, a subordinate network class was also created to allow for relationships between assets based on an attribution as opposed to spatially. This then allows for additional documentation to be associated with these subordinate networks, for example, based on the criticality, size, or voltage. To further reduce the hard constraints on the database, we incorporated a soft typing approach to the feature classification, having general feature types, then specified types captured by attributes. This reduces the need to create new tables each time we came across a different feature type that needed to be captured. This also makes reconfiguring the front-end software which visualizes the data much easier. Another learning was the method with which we used code lists to harmonize the attribution of the data. It was key to the outcomes that the attributes were harmonized, the granularity of which was defined by our use case. Instead of incorporating the code list, however, within the model itself, we have maintained them as a separate register. This way, they can be changed and updated without having to republish the model. Further, we learned that in some cases, despite our requirement to have harmonized values, some asset owners may believe there is additional value added to the end user by maintaining their original value. To allow for this, there is an incorporation of the type description attribute, which is a string value, allowing the original value from the source table to be incorporated. Flexibility was also considered in terms of the structure to capture different geometry types. We have used a database that allows multiple geometry types within one table. This allows for the eventuality that different asset owners will capture similar data or asset types in different ways, and this is impossible to predict. Again, this flexibility allows for a simpler structure in the data model and less creation of duplicated tables simply for the purpose of different geometry types. These items and others were fed back as key learnings from the pilot, and within the preparation phase, we got to work on remodeling the data model for the next phase of the project. So after all this effort and planning and refining, you would hope that we got the model perfect so that when we started again from scratch with the build phase, the data model wouldn't need any changes and it would all go smoothly. However, as I'm sure most of you know, this is not the nature of data. We captured all those learnings in a new version of the data model and baselined it as version 2. But as expected, when real data started to flow into that version, we again began to see there were still changes needed. As this was to be expected, we had set up a process within the governance of the project to allow for careful oversight of the changes and ensure the impact of the changes did not undermine the feasibility of the project, and this was key. So how did we manage these changes to the data model? They were managed closely due to the impact the changes could have on mostly and quite heavily the transform data itself. There we have a strict process of review, which includes a data model governance group, or a DMGG, where the changes are thoroughly discussed before being agreed. A large part of the discussion is about the impact assessment across the whole data journey to ensure the changes are timed appropriately for the impact. Changes are bundled up for formal review and are implemented in groups to allow for easy management of the change and versioning of the database. The impact is often greatest on the data that is already transformed. So building a solution that can cope with the expectation of change has been a key focus across the whole team. Having early sight of these changes has also helped to inform the process, allowing more time to consider these changes. This has been enabled through our close work with asset owners with our engagement team, who work to understand their data before it is passed over to our data teams for transformation. This insight captured from this team is crucial for the success of the data transformation. Some changes that we've seen already. So some examples of the changes we've seen so far include the refinement around the conventions and the hierarchy of identifiers within the database. It has been important to have very clear levels of inheritance for the identifiers used within the data model, and also to have a proper way of dealing with the data when the asset owners cannot provide unique identifiers. We've had many a discussion around identifiers, and these have been incredibly useful to refine conventions around this feature of the data model, but also to instill best practice across the team and hopefully beyond. I think there are many asset owners out there that don't have or see the importance of unique identifiers within their database. And I'm hoping that highlighting the importance to them is one of the positives that will come from NUAR as the benefits are fed back into industry. We have also created additional feature types as we discovered more data, which we did not encounter during the pilot. This can be due to engaging with different asset owners or due to the increased awareness of the project. Asset owners often think more about the data sets and what could be also useful to be viewed on this centralized platform. There are also sources of this sort of change through the engagement with other change projects and understanding how the streetscape will be changing in the near future. Things like the increase of EV charging points. As interoperability is a big issue when looking at data quality, we have also incorporated within the data model the ability to capture unique codes which are used in complementary systems. This opens up the potential for future integration with systems such as the Streetworks process within the UK. Looking for more examples of this kind of interaction can further increase the value of the NUAR platform into the future and increase the value of the data on which it's based. There's also been regular changes to the code list values, which has already shown us the value of holding these code lists separately from the data model. This has reduced the impact of these changes significantly already. And lastly, ensuring that the data types within the fields are easily accessible by multiple different systems, and that we won't be building in system dependencies because of the data model design. This is something that has been considered and modified. This sort of change can help ease larger system changes later down the line in the project, and as more and more systems start to transform the data and feed it into the platform separately. In terms of a bit of update of where we are along this stage of the build phase, so far we have engaged with all 250 asset owners in the 3 initial regions, but we also have, as well as the data things to consider, we also have legal complications to getting that data, or challenges, should I say, around how we get that data. So we have a data exploration agreement, which 88 of our 250 asset owners have already signed. This allows the data to be explored and we can start transforming it to the target schema. Of those organisations, 42, after signing that, have already shared the data with us, and we've been able to transform over a dozen data sets to the single NUAR harmonised data model. We then have a more heavyweight legal agreement, which is the data distribution agreement, of which 3 organisations have signed. This allows us to expose the data on the platform when it is built and ensures tight legal compliance around how the data is used and who it is shared with. So what could the future hold? In terms of the future benefits, they could go far and wide. It could bring about positive change by giving the industry a standard to aim for. We are already seeing companies use the data model as a basis for creating their own data sets, and also as a prompt to start discussions within their companies about their existing schemas and what they really should be holding and the sort of level of quality they should be aiming for. If more companies look at a standard to inform the decisions around their data management, this will lead to an improvement in the interoperability of data across the industry. There is also the possibility that there is an increased need for digital and data skills. As these areas continue to grow and value is gained, there can be a shift with the upskilling opportunities created across the industry as well as the public sector. So thank you so much everyone for listening. There's our socials. I'll take any questions now.
Thank you so much for that, Amy. So yeah, it's the Q&A portion of the talk. Please use the Q&A tool to put any questions in. Maybe I'll start us off, Amy. So these are fairly recent efforts that you're making. We've heard over the last 2 days from efforts in France, efforts in Singapore, some of the work that's been going on in the United States. Was there a particular incident or series of incidents that raised the importance of creating the NUAR system? Like, what brought it about?
It came out of an innovation festival, which happened within, it's one that for every year for about 3 or 4 years now, Northumbrian Water in our northeast holds, where it gets together a lot of industry specialists and just brainstorm about problems that we're currently seeing in the industry. And this was actually something that came out of that brainstorming session, and started to discuss what are the complications around that in terms of the legal as well and the data side. Is like, how do we do this? Is it possible? And that's really where it started. So from industry. From industry,
very interesting. Okay, so we've got a bunch of questions that have come in now on the Q&A. So what I'm going to do is just read them out for everybody to hear. So first question from Jonathan, he asks, does NUAR store data as EPSG 27700 British National Grid, ?
I believe that is the standard that we're using for the spatial, yes.
Another question, who will pay for the service? Is it the asset owners or the users, public and contractors?
So currently the build phase, so up to September 2024, when it's rolled out across the country, is currently funded through the Geospatial Commission. But past that, it's still to be determined. So we have a separate team within the Geospatial Commission that is looking at exploring all these future cases, who will pay for it, and how exactly it will work. So yeah, it's still a lot of discussion going on in that area.
Another question. Hi, Amy. Do you think the data model could work outside of the UK as well, for instance, in Canada is the question.
Yeah, absolutely. So the Geospatial, the Open Geospatial Consortium, it's an international body, and the core MUDDI model is an international standard. We use the UK excavation profile, but there'll be different profiles depending on the country and use case, because of course you have different terminology and there's different sort of location specific elements there to be incorporated. But yeah, absolutely. You just probably wouldn't use the UK excavation model. You'd a profile of that model. You'd use the Canadian excavation profile.
Another question. What happens if asset owners don't feel comfortable and refuse to share their data? Will the project go ahead without full coverage?
So by law, all asset owners have to share their data when requested, not necessarily by us, but when people are digging in the street. So currently it's already a requirement that they share their data. There are definitely concerns about sharing it on a centralized platform like this, but we are doing absolutely everything above board in terms of security to ensure that that risk is mitigated. And yeah, we'll just be working with asset owners to make sure that they're comfortable with that, because we're doing everything we can to enable that.
Question from Jean-Loup. In your data sharing agreement, how do you deal with secrets related to commercial competition?
In terms of how people will, I'm not sure exactly the lines in the data sharing agreement, but in terms of the way that we'll be displaying it and the way that people will be restricted on the platform is that you can only view the data within the area that you supply. So therefore that stops you being able to view all the different other companies around your other competitors, because you can only view your area. Because why would you need to see out of your area if you're digging a hole there? So there's also security measures around people taking subsequent screenshots along a line. So we're doing tracking on that to make sure that that doesn't happen as well.
Will it be able to be used by anyone or select people? Maybe they're referring to access to the data, I'm not sure.
So currently it's going to be only available to statutory undertakers, so the utility companies themselves, as well as their supply chain. So they may have the contractors for, let's say, Thames Water, a big water company in the UK. They may have contractors who are digging the hole and they would have access, but currently the use case only allows for access to statutory undertakers and their contractors.
There is already a similar service called Line Search Before You Dig. This service is live since years and services all the major critical asset owners. It seems that NUAR has not considered to collaborate with this service. Why not?
We have collaborated with them, and we've spoke to them. This model is slightly different in that we are comprehensive, including local authorities as well. There are some other differences. But yeah, we have been in discussion with this, but this platform, NUAR, provides a more comprehensive solution.
Another question from Shane. Under the NUAR, who is issuing the plant maps and as-builts? Is it the governing body or individual utility asset owners?
So it's all visualized through a centralized platform. So there's not necessarily an issuing of as-built or drawings. You will view it sort of like Google Maps, but with a view of all the pipes on that street, for example. The asset owners give us that data, and that's why we transform it into our single harmonized data model, so that we can view it as in a single view on a map, as opposed to on all those different as-laids and as-builts.
How do you verify that the request for data is legitimate, or as an info-seeking exercise for competitors of the same utility services?
So there's very strict access controls. These will be limited depending on the role, and how you're given the role will be stipulated by the asset owner. And like I said, you can't view outside of your patch where you supply to allow for that risk to be mitigated. Yeah, I don't know how further to sort of answer that question. Sorry. I hope that goes some way to answering it.
Yeah, no worries. There's another question here from Jenny. You mentioned access for utilities and their suppliers. Are there public record laws in the UK that come into consideration for the data sets?
I'm not sure about public record laws. Sorry.
No problem. How do you handle military or government secret subsurface infrastructure? You will still need to tell the diggers where not to dig, but that's essentially admitting something is there.
Yeah, so we're working very closely with MOD, the Centre Protection of National Infrastructure as well, which is a really important body within the United Kingdom for managing that sort of risk. So we're basically just following their guidance on that. And I won't go into the details about how that's dealt with.
Well, that's the last of our questions, Amy. Thank you so much
Great.
for taking the time to share what you're doing. It's very interesting. There's a lot of people all over the world looking at all these new developments in different jurisdictions when it comes to underground infrastructure mapping. Standards are a big part of that. So again, thanks for being here.
Thank you so much. And if there's any questions that I haven't answered properly, there's a Geospatial Commission email address on there as well, if anybody wants to email there.